Alright, so this question is called implement queue using stacks. It says implement the following operations of a queue using stacks. Push, which pushes an element to the back of a queue. Pop, which removes the element from in front of the queue. Peek, which gets the front element. And empty, which returns whether the queue is empty. So it gives a little example over here. It instantiates a new queue. It pushes two elements and then uses peek. So this returns the element 1 because that's the one at the bottom of the queue. Then it pops the one at the bottom of the queue and returns the number 1. And then it returns whether or not it's empty, which it's not because there's still one element left. Notes, you must use only standard operations of a stack, which means only push to top, peek pop from top, size and is empty operations are valid. Then it says depending on your language, stack may not be supported natively, which is actually not in JavaScript. You may simulate a stack by using a list or a dequeue as long as you use only standard operations of a stack, and that's what we're going to do. You may assume that all operations are valid. For example, no pop or peek operations will be called on an empty queue. Alright, so let's go over to the code that LeetCode has provided. So this is the class called myQueue. They want us to implement a push method, which just adds an element to the top of a queue. They also want a pop method, which removes an element from the bottom of the queue. Then we need to implement peek, which shows us what element's at the bottom of the queue, but doesn't actually remove it. Then we have an empty method, which just checks whether there are any elements in the queue. And like I said before, JavaScript doesn't have a stack class, so I implemented one on my own. I won't go into the details of this too much, but just know that all of the code and the written explanation is linked down below. So with the stack, when you push it, you add an element to the top of it. When you pop it, you remove the element from the top. Peek shows you which element would be removed, which is the element at the top. Empty shows whether or not it has any elements in it. And then size shows you how many elements are in it. So let's quickly go over the difference between a stack and a queue. A stack is commonly referred to as LIFO, which stands for last in, first out. This means that the last element that was added is the first one that's going to be removed. So let's picture a stack of dishes. Even though the element at the bottom was added first, the first element that we're going to remove is the one at the top. So let's remove that one, followed by the next most recent, and then the next most recent. Let's go over to a queue. A queue is just the opposite. It's first in, first out. So whichever element was added first is going to be the first one removed. So let's picture a line at a grocery store. This person entered the line first, and then this person, and then this person. The first person to enter the line will be removed first, then the next person, and then the person after that. And just to demonstrate that one more way, let's go to the LIFO stack. This is first, second, third. Which one's going to be removed first? The last one added, the one before that, the one before that. Over to the queue. This is added first, this is added second, this is added third. Which one's going to be removed first? The oldest one added, then the one after that, then the one after that. Alright, so how do we make a stack behave like a queue? Remember that with the stack, the last element added is the first one that's going to be removed. So with the stack, let's say we add 1, and then 2, and then 3. With the stack, the first element that would be removed is the number 3, but that's not what we need. We need this to behave like a queue, where the first element removed is the oldest one, which is the number 1. So how are we going to go about doing that? What we can do is we can actually use two different stacks. So this is stack 1, and this is stack 2. And what you're going to do is anytime you want to remove an element, you first check whether stack 2 is empty, which it is. So then you look at stack 1 and you remove all of the elements that are in it and put them into stack 2. Then you're able to remove whatever elements at the top, because now what we've done is we've effectively flipped the original stack into the second stack. All right, so you want to remove one, you can remove this, which is the oldest element added. What's the next element that was added after that? It was the number 2. So if you want to remove that, it's as easy as looking at the second stack. So let's say we want to add another element. Where do we add it? We always add elements into the first stack and remove them from the second stack. So you want to add the number 4, put it in stack 1. You want to add another element, let's say 5, put it in stack 1. Now you want to remove an element. You look at stack 2, and if it's not empty, you remove whatever is at the top of it. Let's say we want to remove another one. Remember, we always look at stack 2 and see if it's empty. It is, so then we have to go over to stack 1 and pop every element in it into stack 2. So now when you want to remove an element, you look at the top of stack 2 and remove that. All right, so let's code this out. As we talked about before, the way to do this is to use 2 different stacks. We'll call the stack that we're going to add things to the push stack, and we'll call the stack that we'll remove things from the pop stack. So this dot push stack equals a new stack, and then this dot pop stack equals a new stack. Let's move down to the push method. Like we talked about, when we use push, we're just going to add everything to the push stack. So this dot push stack dot push, and what are we pushing? The variable x. So pop is a little more complicated. Remember, what we're going to do is we're going to look at the pop stack. If it's empty, we remove all of the elements in the push stack into the pop stack, and then we remove the top element. So let's do that. So if pop start, this dot pop stack is empty, so if there's nothing to be popped from the pop stack, we need to remove all of the elements in the push stack and add it to the pop stack. So while this dot push stack isn't empty, this dot pop stack dot push, this dot push stack dot pop. I'll explain that again. So this is saying while the pop stack isn't empty, while the pop stack is empty, so there's nothing in the pop stack, we take everything from the push stack and we put it into the pop stack. And we do that over and over until the push stack is empty. And then what do we need to do? We need to return this dot pop stack dot pop. So the first thing at the top of the pop stack. All right, moving down to peak. Peak is actually pretty close to pop. Use the same logic. First, it checks to see whether the pop stack is empty, and if it is, it takes every element in the push stack and then adds it to the pop stack. Hold on, let me just reformat this. The only difference is at the very end, it doesn't pop, so it doesn't remove what's in the pop stack. It just shows you what's in there. So this dot pop stack dot peak. And then for empty, we need to check both of our stacks to see if they're empty, and it can only be empty if both of them are empty. So return this dot pop stack empty and this dot push stack empty. All that means is that if one of them has any elements in it, then the total queue is not empty. So let's run this code. Looks good. Submit. And it worked. So this was faster than about 41% of JavaScript submissions. So as usual, all of the code and explanations are linked down below. See you next time.